Good evening, boys and girls. Welcome to another lesson on Technical Sciences Grade 12. It's a beautiful Friday evening, the 16th of October 2020, and I hope you are having a great day. Remember now the exams are nearing, and I hope that you are really preparing well for your upcoming examinations, and that we are really doing well in technical sciences for your preparation. So thank you for joining me. We will be continuing with our lesson as planned in electromagnetic radiation. And remember, tomorrow we are having a question and answer session. So we will be concluding the topic tomorrow. Let us look at the outline of the lesson for today. So in our overview, we will be looking at electromagnetic radiation as per the examination guidelines. And then in the features of the topic, we will definitely be looking at electromagnetic radiation, and we will be looking at that using questions on electromagnetic radiation. And I will also be giving you more tips in terms of exam preparation and mark allocation for this particular topic at the end of the year. Remember, this topic forms part of paper 2. Secondly, it is a topic where you can really collect all the marks, and I want you to really do well in this section of the work. So let us look at what is required of us as per the examination guidelines. 1, we must be able to define an electromagnetic wave. And we define it as a changing magnetic and electric field mutually perpendicular to each other and the direction of propagation of the wave. And for that, you know you will definitely get 2 marks. And then you must be able to discuss the properties of electromagnetic waves. And I told you that you must know at least 4 of them altogether, because at most we will ask you for 4. And we've stated them each and every day since Monday, and I'm sure by now you know them. And we must be able to use the equation C is equal to F multiplied by lambda to solve problems that involve speed, frequency, as well as the wavelength of a particular light or any given electromagnetic radiation. And I told you that you can also use this formula, which is the one that you actually get in your formula sheet, where the speed, which is V, is equal to the frequency multiplied by the wavelength, which is the lambda sign. Then we must be able to discuss electromagnetic spectrum in terms of frequency and wavelength. In other words, understand what is the relationship between frequency and wavelength when the speed in a particular medium is constant, which electromagnetic waves have a higher frequency, which ones have a lower frequency, as well which ones have a longer wavelength and which ones have a shorter wavelength. Furthermore, we must be able to arrange them in that particular order, either an increasing frequency or a decreasing frequency, or an increasing wavelength or a decreasing wavelength. Furthermore, for each electromagnetic wave, we must be able to give its uses altogether. And a couple there, we know we must be able to give the disadvantages of those electromagnetic waves. Another important definition in this section is where you are able to describe, or rather to define, what a photon is. And we know a photon is a quantum of energy. And we know that definition for now. And it definitely will give us 2 marks, as it is All the keywords must be there and they must be in their correct context. And then we must again use this equation is equal to HF to do calculations that involve energy, frequency, and the wavelength altogether. They must then be able to calculate the energy of given photon of electromagnetic waves, or simply the energy of electromagnetic wave. And we know the H is definitely the Planck's constant in the data sheet, and F will be the frequency of that electromagnetic wave. And if you are given the wavelength, you will say the energy then is equal to the Planck's constant, which is H, multiplied by C, which is the speed of electromagnetic waves in a vacuum, which you will get from your data sheet as well, divided by the wavelength altogether. And we also know the units. Remember, energy is measured in joules and the wavelength is measured in meters altogether, right? And there are the values. Remember, from your formula sheet, or rather from your data sheet, you will get the speed of light in a vacuum C, and it will give you 3,0 times 10 to the power of 8 meters per second. In other words, this is a value that you are not supposed to calculate. It's a value that is given to you altogether. So given a formula, you must know that when you want the value of C, you will definitely get it from the data sheet. And then the Planck's constant, it's H, and its value is 6,63 times 10 to the power of negative 34 joules seconds. And we also get it from the data sheet. And then in our formula sheet, there we have that table too. We get formulas under wave, sound, and light. So these are the topics that are relevant because we are dealing with waves, electromagnetic waves. So V is equal to F times lambda. It means speed is equal to frequency times wavelength. E is equal to HF, meaning the energy of the light is equal to the Planck's constant multiplied by the frequency. Or the energy is equal to the Planck's constant multiplied by the speed of light in a vacuum divided by the wavelength. But remember, I always tell you that C basically represents the speed of electromagnetic waves in a vacuum. Now, that's essentially what we need to know in terms of examination guidelines. Now, here is a question, and let us see how best we can answer this particular question. It says, the diagram below shows the different radiations of the electromagnetic spectrum. They are arranged according to their increasing frequencies. So, dear my learners, we can see an arrow and it's going up. It means this is the arrangement that they are talking about there. And I can see it's going from radio waves to microwaves to infrared rays to light, and we know rather to visible light altogether. From infrared rays, then it definitely goes to visible light. And then from visible light, we have ultraviolet light, and then we have X-rays and we have gamma rays. The order there that I've just read, my dear learners, it's an order of increasing frequency. In other words, radio waves have the lowest frequency. They have the lowest frequency. In other words, again, in terms of wavelength, it means they have the longest wavelength. We know this is a symbol for wavelength. And then gamma rays, they definitely have the highest frequency, but they definitely have the shortest wavelength. Remember that, my dear learners. Again, you look at visible light there, and there we see all the components of visible light. Your red, orange, yellow, green, blue, indigo, violet, and it is still the same order. It's an order of increasing frequency. In other words, red light has a lower frequency and violet has a higher frequency. And red, we said it has a lower frequency. In other words, red has the longest wavelength, and then violet definitely has the shortest wavelength. Right, we go to questions. We are required to define an electromagnetic wave. Now, we all know by now, when we talk about an electromagnetic waves, we are talking about changing magnetic and electric fields that are mutually perpendicular to each other and to the direction of propagation of the wave for 2 marks. And there it is. Changing magnetic and electric field mutually perpendicular to each other and the direction of propagation of the wave. And that is going to give you 2 marks. Then we are required to give 3, right, industrial applications of electromagnetic radiation. Now here, my dear learners, they did not specify the type of electromagnetic radiation. In other words, all the uses that you know that apply to the industry, to the economic sector, to the working industry, in technology, those ones that we are using, then they are going to be relevant there. Now, we can think of a couple. Number one that you can think of is that gamma rays, for example, they are used for food irradiation altogether because they are used to kill all the harmful germs or small organisms, microorganisms that can cause the food to rot quickly. The same again with gamma rays. Remember, they are used in the medical industry to sterilize medical equipment. They are used to sterilize medical equipment. And the same applies to ultraviolet radiation. It is also used in the industry to sterilize medical equipment. Again, my dear learners, you can think of X-rays altogether. X-rays in the medical industry, it is used to examine broken bones. Right? It is used to examine broken bones. Another important use, my dear learners, of electromagnetic waves is that in banks, it is used to detect counterfeit notes. Right, and we can give more and more in the industry altogether. So I will just write this for, it is used to detect counterfeit notes. Are we together? You can think of, this detection of counterfeit notes. It uses ultraviolet radiation altogether in banks. Furthermore, one could even talk about X-rays, because X-rays are also used in security scanners to check if people do not have any harmful objects in their bags and so on. So you could really talk about that. Nice question, because it really did not specify exactly which type of electromagnetic radiation you should talk about. And then we are being asked again, why are ultraviolet rays considered to be harmful radiations? And this is simply because overexposure and you will talk about that. Overexposure, there we go. It is simply because overexposure to ultraviolet rays can lead to skin cancer. Remember, my dear learners, we get ultraviolet rays from the sun, and if you are exposed to them for a long time, you risk getting a condition that we refer to as skin cancer. So overexposure to ultraviolet rays can lead to skin cancer. And that is why, my dear learners, you must not be in the sun for a long time. 5 minutes is enough. Warm yourself up and then you move on altogether, because if you're exposed to them, they become harmful, and that overexposure will lead to skin cancer. So very critical that we talk about overexposure. I mean, if you are not overexposed, then you may not necessarily have a problem or a condition that we call skin cancer altogether. So overexposure, very key, and can lead as well, very key. Not always going to be the case that it will cause skin cancer, but it's a risk factor. Then in 9.4, we are required to calculate the energy of a photon of electromagnetic wave with a wavelength of 650 nanometers. So firstly, my dear learners, remember we want to calculate the energy. In other words, we want to calculate the value of E, the energy of that photon, and we've been given the wavelength, and the wavelength has been given in nanometers. So what are we supposed to do there? Firstly, we can see that this value has to be converted to meters, because in my formula, I cannot substitute my wavelength in nanometers. I have to substitute it in meters. So for that, I'm going to say, to convert from nanometers to meters, all I have to do is to take the value as it is. We've talked about this one, 650, and you will multiply it by 10 to the power of negative 9. And that is going to be in meters. Altogether, my dear learners, that is definitely going to be in meters. Remember that. Now, when that is the case, it means you are ready for your calculation. So let us perform question 9.4 there. Let us get a nicely different color. 9.4. Right. We have two options in a formula, or formulae rather. We could use this one, but we can't use this one for now. Well, we actually can, but we don't prefer to use this one because it talks about frequency. So it would require us to do a multi-step calculation. But this formula there, E is equal to hc over wavelength, would not require that of us. Are we together? Because it already has the wavelength. So we will say E is equal to H multiplied by C divided by the wavelength. And then the value of H, we know it is the Planck's constant from the data sheet, H there, C there. So you don't need to calculate them. You get them from the sheet. 6,63 multiplied by 10 to the power of negative 34. And then the value of C, it's 3,0 multiplied by 10 to the power of 8. And I will divide that by the wavelength. And the wavelength we've already converted to meters. So it will be 650 multiplied by 10 to the power of negative 9. And this is going to give me, we go to our calculator. Six 6,63 multiplied by 10 to the power of negative 34 multiplied by 3 times 10 to the power of 8, yes, divided by 650 multiplied by 10 to the power of negative 9. And there, my dear learners, we get our answer as 30,6 multiplied by 10 to the power of negative 20. And our answer there is going to be in joules. Altogether, fairly easy, my dear learners. 1 mark there, 1 mark for the substitution in the numerators, 1 mark there for the denominator, and 1 mark there for the final answer with the correct unit. Altogether, so we are getting, so there's definitely a mark for everything. So we're getting a mark for the formula, for that Planck's constant, for the speed of electromagnetic waves in a vacuum, for the wavelength, as well as for the final answer with correct units. And the answer is joules. Then in 9.5, they say to us, suppose an electromagnetic wave of wavelength 665 nanometers is available. Instead, how will the energy of this photon compare with that calculated in question 9.4? Write only greater than, smaller than, or equal to. So now, my dear learners, we are going to use, now remember we are comparing the energy that we will be getting from this one. The one with the wavelength of 665 nanometers to the wavelength of 650 nanometers. Now, what I definitely see there is that they are now using an electromagnetic wave with a longer wavelength. Why? Because in 9.4, the wavelength was 650, so it was shorter. So now in 9.5, the wavelength is longer because it is 665. Now, if I make the wavelength longer, it means my frequency, which is F, decreases. Now, when frequency decreases, it means the energy is also going to decrease. Why do we say that? Because we know that frequency is directly proportional to energy. The higher the frequency, the higher the energy. The lower the frequency, the lower the energy. So if you start to use a wavelength, an electromagnetic wave with a wavelength that is longer, it means now the frequency has been decreased. And if the frequency has been decreased, it means that the energy is also going to decrease altogether, because energy is directly proportional to the frequency. As a result, our answer there is that the energy of this one in 9.5 is going to be smaller than the energy of the electromagnetic wave in 9.4. Right. Now, we look at another question. Consider a laser pointer and a cell phone as shown below. So there we have a laser pointer. We know we use it in presentations and so on. And we also have a cell phone. And we are required in 8.1 to state the type of electromagnetic radiation that is emitted by the laser pointer. Right, I want you to think about this one. Now, definitely a laser pointer is giving me infrared radiation because it is used for signaling altogether. It is used for signaling, just like remote controls that use signaling. A laser pointer will do the same thing. It will use a signal for communication. So it definitely gives us infrared rays. And then cell phones, we definitely know that they use radio waves. Why? Because radio waves are used for telecommunications, which is what a cell phone is for, telecommunications. So there we definitely use radio waves. Then we get to the next question, 8.2. A laser pointer uses red light photons with a wavelength of 620 nanometers. Define the term photon. We definitely know a photon is a quantum of energy. It is a quantum of energy. Right. And then We are required, okay, this one we definitely know that it will give us 2 marks altogether. We are required to then, in 8.2.2, to calculate the energy of a red light photon. Then, to calculate the energy, we have seen there that this laser pointer uses those red light photons with a wavelength of 620 nanometers altogether. So, we definitely know that. We can say this is the relevant formula. Why? Because it will make it easy for us. We will be able to calculate E, which is the energy that we are looking for. And then we have H, we have C, which we are going to get from the data sheet. And we also have the wavelength altogether. And then for the value of H, we are going to say it is 6,63 multiplied by 10 to the power of negative 34. We will have C, which is 3,0 multiplied by 10 to the power of 8 divided by the wavelength. And remember, the wavelength there is given in nanometers. So we are the ones that must then convert it to meters. And I told you, you will take the value as it is and you will multiply it by 10 to the power of negative 9. And now our answer will be in meters. So there I will divide by 620 multiplied by 10 to the power of negative 9 meters. And this is going to be equal to, we go to our calculator. Right? So it's 6,63 multiplied by 10 to the power of negative 34. And we will multiply that by 3 multiplied by 10 to the power of 8. We will divide that by 620 multiplied by 10 to the power of negative 9 altogether. And the answer that we are getting there is definitely 320,08, and that will be multiplied by 10 to the power of negative 20, and our answer there is going to be in joules. And that was for 6 marks. So 1 mark there on the formula, 1 mark there 1 mark there, 1 mark there. Definitely a mark for converting nanometers to meters, and a mark for the final answer with the correct magnitude as well as the units. And then you are required to get all these 6 marks, my dear learners, because it's really an easy calculation. And I really want you to take it in that way, that it is easy, and then you will be able to do well. And then 8.2.3, refer to the answer to question 8.2.2 and explain why it is dangerous to shine a laser pointer into a person's eyes. Why it is? Because the rays from the electromagnetic waves of this laser pointer have a high energy, and because they have a high energy, they can penetrate through the eyes and cause a loss of vision. And it can definitely cause a loss of vision. These laser pointers, my dear learners, they have a high energy, and their rays, they can penetrate through the eyes, and that can cause a loss of vision. So that is very, very important to note altogether. Right. So please be aware of that, even when you use your laser pointers for presentations and so on, my dear learners, ensure that you do not point it into anybody's eyes, because really these lasers are dangerous, and the rays can really penetrate through the eye tissue, and that can cause a loss of vision. And that is why it is very dangerous for you to shine a laser pointer into a person's eyes altogether. So very critical, my dear learners. Remember all of that. Remember all of that. So be safe out there altogether. Right. Lastly, remember now, this topic is plus minus 12 marks. It could be quite more than 12 marks. Not far from 12 marks, definitely. So ensure that you are able to collect all the marks. I will see you then tomorrow in our question and answer session, and where I give you a summary of all the tips on this particular topic in preparation for your examination. Thank you so much for tuning in, and enjoy the rest of the evening. Goodbye.